So, good morning, everyone. Hope everything is going well with TechEd in Madrid. So, we're going to start with the first part, is who the hell are you? And my name is Nuno Godinho. I'm Director of Cloud Services for DD Technologies, which is a company which is a global software integrator. Works with several companies, enterprise, ISVs, in helping getting them into the cloud, do the cloud journey, and doing things, crazy things like disaster recovery in Windows Azure and getting their businesses there. And we're in the top 3 partners of the year, Windows Azure, and I'm also Windows Azure MVP. So let's see how this year goes in WPC about getting the 4th year in a row in Partner of the Year. Let's see. So that's my blog, Twitter. I haven't been blogging that much, at least the last month, because I've been flying more often, so I've been too much in the clouds, literally. And so I haven't blogged that much. But normally there's a lot of blogs related to Windows Azure, like taking the best out of virtual machines. And there will be, for some reason, there will be a series coming out about, who would have known, disaster recovery in Windows Azure. So let's start, and the outline will be basically a quick introduction into the disaster recovery theme, understanding a little bit of the baselines, and then we go and we will show some examples of implementing several different strategies of disaster recovery with Windows Azure and some of the tweaks we should consider. So, as a call out, this session does not have demos, because for some reason in my personal account I was thinking of putting, let me put something like 10 instances here, then failover, and in order to put the HA scenarios, hot, cold, warm, DR, and all that stuff. And for some reason, I didn't like the cost in my credit card. And so I decided, okay, let's go for the architectural slides, and then I will provide some demos through the blog. Okay? Okay, so introduction, and then diving into the R options. So the first thing, and the key takeaways for this session, is actually understanding our options. When we do VR, what are our options? One thing, how many of you are using Windows Azure? How many of you, even not using Windows Azure, have disaster recovery in your applications? Woohoo. Right? Only a third of the room. Do you need a VR strategy for your applications? That's always important. There needs to be a VR. For example, a real-world scenario. We're all IT people. We have a community. I was based in Portugal until last year. And we have a community. It was the .NET developers in Portugal. And we have blogs and everything, and we have that thing in a virtual machine, in one of the vendors. Okay? Virtual machine, everything was done. So we didn't have a disaster recovery strategy. Actually, we didn't have a backup strategy also, but that's another thing. And suddenly, for some reason, that VM went down. So fortunately now, we have a backup, 1 year old. Is that good for the business? Should we consider having backups and disaster recovery or not? Probably yes. And everywhere, and one of the misunderstandings is that, no, but DR is costly. There are solutions in order to do DR which aren't actually costly. There are no costs involved. So let's go through it. So another one is understanding some of the best practices in order to implement this into Windows Azure. Windows Azure has a lot of different features and capabilities. How will we make sure that our application has a disaster recovery strategy, which is a set of processes, and actually can provide what we need in terms of recovery time for the application? And how to choose. So in order to start off, a quick introduction. So we already asked who has a disaster recovery strategy. Only some of you raised their hand, but I think most of you have a disaster recovery strategy. Do you agree? Maybe something like this, like, yeah, our disaster recovery strategy is when something happens, we run down the hall and insult someone. Have you seen this in companies? I have. It's pretty fun. It's pretty fun if you're not in the other end. But it's fun. So in order to get this, disaster recovery is basically about us getting and preparing a set of processes that will allow us to get things like how are we going to cope with hardware and software failures? How are we going to cope with people problems? How are we going to cope with so many things at the same time? So what we are going to do is invest time and resources understanding this and providing a set of architectural designs and also a set of processes that will say, if this happens, this is the way to turn around. Because how many of you in your business have SLAs to customers? When you have an SLA to customer, does your SLA actually tell something like, oh, okay, we have 99.95 for you, and we're going to actually try our best in order to get the 99.5. If we can't, sorry. Does this work? There's actually some SLAs like that. I'm not going to say the name of the company, but there's actually some. They are pretty interesting. And others that have SLA, we provide 99.95, and then in very short letters, they have something like maintenance windows and some things like that are not considered. So it's the same thing as saying, we'll give you whatever you want, we put it in the paper, but we are in the short lines, we're still covered. So in the end, we are the ones that have the problems. So, and it's also disaster recovery, a continuous project. It's a continuous improvement process. There is nothing, the DR strategy is never closed. Everything is changing. Every day there's something new that you need to consider. So it's a living thing. It's not something that you can use. So important things, important considerations to understand is, for example, the recovery point objective. Who can tell me what the RPO stands for? What exactly? Yes? Exactly. So recovery point of objective is how much time ago do we have something in order to recover to? So I'm doing, for example, SQL Server, I'm doing hourly backups, transactional logs, then I'm doing daily differentials, and I'm doing weekly full backups. So recovery point tells us until what point is for us important to roll back. And this will provide us, it's not related to the SLA, but it will provide us, if something happens, how much data do I lose? How much time can I cope with losing the data? 5 minutes? 1 hour? 1 day? Then we have another, which is RTO. Are these new things for, has anyone already know this? Okay. So RTO is actually, okay, now the disaster happened, how much time can I actually take in order to recover. Oh, I have all the backups. The backups are doing hourly. Everything is good. But the backup is actually 1 terabyte or 50 terabytes or whatever. So yeah, my disaster recovery strategy is restore the database, 50 terabytes. Is that going to work? Yeah, it should be fine. It should only take a few days to recover. Yeah, no problem. So this is really important. And when you are doing and choosing a strategy, you need to play with these two values. Recovery point objective and recovery time objective. Because based on them, you're going to choose the right strategy for your business. So one thing which is important also to understand when doing disaster recovery is the performance. We cannot have performance of the application being affected by the disaster recovery strategy. Or at least we need to understand how much that is going to get impacted. For example, if I have SQL servers and I now use merge replication. Everybody knows SQL Server merge replication? So it's a real good thing. You're getting both of them are going to get synchronized, and even we can use transactional or snapshot. Now, fortunately, with 2012, we already have the always on, which is faster. But a lot of things still use SQL 2008 R2, for example. And if we use transactional replication, for example, that means that when the replication is happening, my database is blocked because it's transactional. Does that affect the performance? If I do hourly, does that affect the performance? Oh, but my recovery point objective is 5 minutes. Yeah, let's just change the transactional replication to 5 minutes. Is that going to work? No, probably it's going to kill the business and to kill the application. Why? Because now it's impacting the performance. Because every time I'm doing this, I'm actually blocking my database, which will block everything else. So we need to consider that all the decisions we do when creating the strategy, we need to think that how are they going to impact the performance, as well as the consistency of the data. For example, all of us, all our applications only use database, right? There's nothing that uses, for example, blob storage, table storage, service bus, things like that, right? We only use a single thing. No. More and more, our applications are using different building blocks. When we do that recovery point objective, when we have backup strategies in order to recover to a certain point, we cannot only do that for the database. We need to do this for everything, and need to be in sync. And we need to understand how is the consistency going to be maintained when we go back to that point. Because if we take a snapshot of the database at one point and a snapshot of the blob, tables, and everything in different timings, probably what is going to happen? Inconsistency. Right? So we need to understand that. And we need to have a strategy that goes and solves that at the same time. Finally, another thing is geographical location. How is the geographical location going to affect my strategy? Oh, I want my RPO to be 5 minutes, but I'm going to communicate between US and Europe. Is there any latency between the two? A little bit. Something like 250 milliseconds. Nothing really important, right? If we're doing the connectivity and sending all over things from one end to the other, of course that will get impacted. That will impact performance and will impact another thing that it's supposedly very important for the business. What is it? What other thing does it impact when we put deployments in multiple regions and communicate from one to the other? Any ideas? Any guess? Cost. For some reason, the business is always thinking about the cost. So communicating from one region to the other gets cost. So it's important also to get that and understanding that DR, the cost of the DR. So just a terminology check, fault tolerance. What is fault tolerance? Fault tolerance is basically our design prepared in order to, if something goes wrong, fail over. So have a failover mechanism. Then we have high availability. What is high availability? If I put, for example, in 2 regions the application, but get, for example, in failover mode, is that high availability? No. High availability is when I have multiple nodes which are fault tolerant, but also are working at the same time. So, for example, if I put one deployment in US East, one deployment in US West, one deployment in North Central US, and then use Traffic Manager, for example, to route the traffic based on performance, then I'm having high availability because all of them are working at the same time. And DR is not more than a set of processes, policies, in order to recover from problems. Does this make sense? Yes? Okay. Another thing which is really, really important is understanding what SLAs mean. How many of you normally provide customers or your applications and define, okay, based on this architecture, this is the SLA? How many of you? 3? 4? Nice. How many of you are consultants and work with customers every day? Did you all already have customers that go to you and the first thing that you ask when you're doing an architecture is, what's the SLA you want? What's the SLA? And suddenly someone comes and say, I want 5 nines or 6 nines or whatever nines. Does that happen? They don't understand, in most cases, what that means. And I have a customer which was in healthcare, and we were doing a project. We were putting things in Windows Azure, and one of the things, the first thing that I asked was, why are you going to the cloud? What are the goals? What are the design tenets? And what's the SLA that you want to achieve? I want to achieve 5 nines. And I said, okay, perfect. That's the business SLA for your customers? Yes. Okay, perfect. I just asked one thing. How deep are your pockets? I don't have a problem. And he was, oh, money is not an issue. And I said, nice, because I want services. Okay, nice. We started. I did the architecture for them, blah, blah, blah. Of course, 5 nines. It has multiple clouds. It has on-premise involved, HA, a lot of different things. By the end, I go with a cost estimation of what that will mean in both all the clouds involved, running costs, as well as on-premise what we would like. For some reason, he didn't like the number 6 million per month. Really? It's just 6 million per month. 5 nines, 6 million? No? It was a big project. So suddenly the guy said, yeah, I think 3 nines is good enough. So it's important for them to understand that. And 3 nines was 2.5 million per month, by the way. But it's important to understand, and also understand, do you want this yearly or monthly? Windows Azure provides you with monthly SLAs. When they say, oh, I'm providing 99.95 on Windows Azure VMs, they're saying they can stop 21 minutes and 56 seconds per month. If they don't have an outage during that month, oops, they do not get to have that same time again. Which means that if we say 99.95 yearly, our design is going, and our disaster recovery strategy and even our architecture for HA is going to be different if they say it's a monthly SLA. Because why? My recovery time objective is completely different. Correct? If anything doesn't make sense, shout or throw something. Okay? Okay, so one of the things that I like to, when I go to customers, is show something like this graph, saying, okay, yeah, we can use whatever SLA you want. You just need to understand this. The less time I get, the less RTO and RPO I get, the more money I spend. Are you good with it? And another thing is, I was having a discussion with a friend of mine just yesterday about SLAs. Because we did an architecture, and suddenly he said, oh, the architecture had several elements. Computes, SQL Azure, and storage. And he was saying, yeah, we have compute, we have storage, so yeah, 99.9 would be our SLA. No, it's not. They can fail at different times, right? And if one fails, the other one fails, the application fails as a whole. Yes, my machines are running, but my database is not there. Yes, my database is there, but my app is not. So it's important to get this metrics. So it's important when you're doing this to compound your SLAs. It's important for you to understand, okay, I have 2 instances in Windows Azure, so I have 99.95. Then I use storage, so there I have 99.9. And then I use also SQL databases, 99.9. So in total, what I actually have is 99.75. Is it good for me? Is it enough? No. If no, then what I need to do is start doing an HA. Why? Because now I have 2 areas that are serving. If one fail, things continue to work. So I actually have more SLA. So it's important for you to understand whatever architecture you do, you should consider the SLA. How many of you are doing this today? How many of you now look at this and think, this might be interesting to do? Nice, I'm getting somewhere. Okay, so one of the things which is typical for DR is redundancy. We normally do redundancy. One of the things that I like to remember redundancy, because I fly a lot, I'm a lot of times in the clouds, is a plane. Why does the plane have 2 engines? In this case, 4, 2 in each side. Anyone knows? Does it require all 4? No. Actually, you can do the trip with 1. Hopefully it won't. At least with me inside. But it can actually do it with 1. So why are there the other 3? Just to be safe. Why? Because I want a bigger SLA. That's one of the DR strategies they have in planes. And I'm glad they have. Yesterday I was on the plane, and suddenly we enter the plane, it gets delayed, and suddenly they say, there is a technical issue, which always helps when you're flying. And suddenly they say, oh, it's nothing really special. Just when we touch the ground, one of the tires blew up. And I was, yeah, now I'm secure, really. Because we have a lot, when you see the tires from the planes, there are a lot of tires. And I asked, how many of them blew up? All of them And I said, yeah, okay, what can go wrong? Redundancy, everything screwed up at the same time. So, nice. But it's nice to know there's redundancy, at least in the engines. At least in the engines. So, in your applications, we need to get redundancy. Why? Some of you might have heard about outages, right? In the cloud. Anybody remembers outages? No? Who doesn't remember outages? Oh, come on. There's never been outages, really, in the cloud. Cloud's perfect. They took all problems away, right? No, they didn't. Hardware fails, software fails, and people fail. And one of the things that I like to point out, because for me it was a myth until I actually see the damn thing. It's like, okay, we were working in a company, and every time at noon, the servers would go down and recover 1 hour later. And we were like, what's going on? And suddenly we went to the event logs, and what was there? Machine was shut down and wasn't shut down properly, was just shut down. And we were, what? Okay, so after a lot of attempts, we tried to do what everybody actually normally does, which is go sit in front of the door from the data center at that time. And there was actually a cleaning lady unplugging stuff. And that was real. I haven't seen that ever. And suddenly I saw it and I said, this is not a myth. I'm going to kill you now. Because it was shutting down the servers just in the peak of the usage, which was brilliant for the business. So people fail. And not only cleaning ladies, also developers. Who here is a developer? Who here does bugs? I don't. Sorry. No, I'm a developer. I don't do bugs. I do undocumented features. I just forgot to document that strange behavior. So, cloud data centers did not took that off by miracle. Did not took all the hardware, software failures. They took part of the people failures, but not all of them. And part was, for example, instead of allowing people to go around the data center, no one goes around the data center. So people out. Very low number of people inside managing the data center. Everything is done remotely. But of course, there are still people errors. Like when there are issues with certificates and stuff like that, leap year bugs and interesting things that happens. So it's important to design for failure. It's important to get that design, which is immediately prepared to scale whenever there is a failure. We need to understand, because there are large failures. There was a failure a couple of years ago that actually took a company which provides online movies in the UK, that actually lost every single movie they had in the cloud. And the reason was they didn't have a disaster recovery strategy, they didn't have a backup strategy, and they felt, yeah, what can go wrong? We're in the cloud. What can go wrong? Just the data center go completely down and you lose everything, nothing else. So the cloud helps, but it's not the solution for all the problems. We need to still have DR and backup strategy. Also, the application itself are ultimately responsible for the availability. It's always like that. We need to get, one of the things that I've been doing in the last few years is provide customers with ability to get more agile in their teams. How many of you use an IT ops model where you have dev teams on one side that go to code complete? When it goes to code complete, hand over to an IT team which is going to support that, monitor that, and some things like that. How many of you? Probably most. How many of you have a single team that has product owner, developers, IT pros, and so on, which are responsible for the project, and whenever there's a support issue, actually the same developers that develop the code will actually be responsible for solving it. It's a more DevOps kind of model. Strangely enough, when you change from an IT ops model where developers go and say, I'm code complete, I don't care, you do it, to a DevOps model where everybody has a shared goal, which is the product needs to be successful, things start to work a lot better. Even the code gets better. Would have known that? Even the code gets better. You start to get more TDD involved. You start to get more re-engineering of the code and everything. So it's one of the models that provides that availability. Also, balance cost and complexity when you think about HA. Am I doing HA just for the fun of it, or is it really important for the business? And finally, the cloud infrastructure and our DR and HA need to think some things like multi-server. Do I need only multi-server? Do I need multi-region, multi-availability sets or availability zones, multi-regions, or multiple clouds, or even hybrid? You need to plan for this right from the start. So, any questions until now? Comments? Personal attacks or other? No? Okay. So now we'll go to the DR options. There are several DR options that we can use. We normally think about cold DR, warm DR, hot DR, and HA. Those are normally the levels that we have in DR. So basically what we have is, if I want a few hours of RTO and RPO, I'm talking about the cold DR, which is the most common. And the reason is simple. It's very cost effective. It's almost nothing, or nothing actually, in order to get this done. Then we have warm DR, which is recommended. Basically the warm DR, we're going to see this, but it's like having a pilot on. Something, a small instance that it's there. If something goes wrong, it immediately skips to the other one and will scale. It's just a pilot that is there. Because there's one thing that you need to remember when you do a DR strategy, which is, okay, I'm going to do a DR strategy in case of the full region goes down. Imagine I'm having everything in my US East, and suddenly what happens is that thing fails. I have a DR strategy which tells me that I have only a pilot on the other one, North Central US, for example, and I'm going to fall back. Does that seem right? One of the problems with that is, when I'm doing this, how many people were actually in that same region where I was? A lot. And basically everybody will be doing the same thing. And so potentially I might find issues of performance. I might even hit some limitations of that region and need to go to a different region. And that's why it's important for you to think about the RTO that you need. So hot DR, less common because it's more expensive. And finally, hot DR with a live. So cold DR. Basically, we have our data center one, which has our application, load balancer, and everything. And in order to do a cold DR, we basically set up a backup strategy that backups database and file storage into another data center, or even on-prem. And if it's on-prem, you're not going to cost anything because you already have the information. And If something goes wrong, what I'm going to do is take the package, take the backups, and restore it again. This is called DR. What's the cost of this? Almost none. What's the RTO for this? Depends on, the RPO will depend on how much backups, what's the timing between backups, normally around 1 hour. That's what's normally being used. And what's the RTO for this? The time to get the recovery should be around 2 hours to 1 day or something like that. It depends on the size of the backups and the strategy. Okay? Does this make sense? What we have here is that we only have one element provisioned. There's no replication. So if we think of Windows Azure, how can we do this? The first thing is actually put this inside the fault domain. Who knows what's a fault domain in Windows Azure? So a fault domain is a way for you to make sure that the machines are in different racks in order, if one fails, the other machine is not going to fail. It's actually in VMs. If we think about this as VMs, it will be done by using availability sets that will provide you the 99.95. So that's the first thing. The other thing is SQL database, for example. What am I going to use in order to do the backup? SQL import export. Basically, I will get a service which will hit and say, get me the backpack, which is schema and data. It's a zip file with schema and data, does not have the transaction log, schema and data, and will provide me the ability to restore at any point in time. Okay? Then, for blob storage, what we are going to have is something like a third-party tool that will provide you this. For example, Redgate actually has some tools in order to provide this, but there's nothing out of the box that you can actually do. So it recovers quickly based on the backups. It's basically leverage SQL import export, and it's very cost effective. Another option is I work with a company. Yeah. Exactly. That's one of the things. You should always consider the cost of that. So it's low cost. It's not a no cost. It's a very low cost because the traffic, it's very cheap. But you need to consider everywhere the cost of what you're doing. You're correct. So this other option, I was working in a company which is actually an airline company. And basically they have a solution in order for you, when you go check in or even when you buy, you can select your seat and buy your seat. Right? So that application was running in Windows Azure. The rest of the application, ticketing system and everything, main systems were on-premise. So we placed everything in Azure, and what we have is another app that is actually running on-premises. So we placed the fault domains. We did backups only from the blob storage, which is basically only a single backup because it mostly uses static contents there. And for the database, we didn't even back it up. Because what happened is every time something happens on the seat allocation, we actually needed to inform the ticketing system on premises. So every time we would get a seat allocation, we would put the message on the queue. That message would be sent to the application, ticketing application, which was stored on that database. Basically now, if this fails, what happens? Since I have everything in my database, I can actually generate everything, use the package, generate all the seat allocation, all the data that I need in order to get in the cloud, and I can recreate the database. Why was this interesting? Because the cost was basically almost none. The only thing was the synchronization between the blobs, but the blobs were changing something like monthly, max, and so was almost none. And the service bus cost. That would be there always, because that's the way the application goes. And so for this, the price of the VR was absolutely zero. The recovery time for this is mostly something like 2 hours, which is inside their SLAs. And the recovery point is actually around immediate, because everything is in there. And the cost is zero. So one of the important things I'd like you to get out with is you can actually, if you get creative, you can actually get VR paying nothing or almost nothing. There's no reason why there's not a DR for your applications. You need to think that. Okay? So, another one is the warm DR. What's the difference for the warm DR? Basically, the difference is we have an application, a data center, one, and we have a second data center, which has also information. We have replication between the two, file storage and databases, and if one fails, the other one actually is going to get called. So we have this in failover mode. The difference between them is that the second deployment will be in the minimal state. So we will have this deployment in very minimal state. So it will be mostly a pilot mode, something, one instance that is running just to make sure the traffic gets in there immediately, and then it will scale up. Okay? So it's minimal additional cost, fairly rapid recovery, more than the cold DR. So in Windows Azure, what we would do would be to get the region. For example, I have multiple nodes, multiple instances in data center 1, region 1, for example, North Europe. And basically in Western Europe, I will have only 2 instances. Why 2 instances? Why did I put 2 instances? Yes? For SLA, correct. Because if I only put 1 instance, what could happen is when I actually turn over for the failover, the application might not be there because I don't have the SLA. With 2 instances, I'm sure I have an SLA. So basically, I will have that. I will have replication. How? How many of you know SQL Data Sync? Okay. SQL Data Sync provides you synchronization between SQL databases, and also with SQL servers. So you have a hub. Basically, the hub is the main database, and everything else, every other nodes will send information to that hub, and that can be both ways, so everyone can be writing, and that gets synchronized. So one of the things it has is it has a limit of 5 minutes. The minimum that you can have for data sync is 5 minutes. And by the way, it actually impacts your performance of the database and creates a couple of tables in the database. It's one option, but you need to get that in mind. Again, for data replication, we would use some third-party tool. And most importantly, Traffic Manager. Who knows Traffic Manager? Traffic Manager is a global traffic manager. It's a global process that basically you have a DNS. It's like a DNS manager where you can put a lot of URLs and say, I want this to route based on performance, failover, round robin. Basically what's going to happen is, in this case, I will have it in failover mode. Why? So I have my main one. If something happens, what I'm going to do is immediately switch to the second region, which will be immediately kick off the auto-scaling, and you can use, for example, the Wasabi. Who knows Wasabi? Windows Azure Application Block, Windows Azure Auto-Scaling Application Block. You can put it in based on one of the things when you use auto-scaling. Do not do auto-scaling based on a single metric. It's not only based on CPU or memory or network. Should be across several elements, even hits and even information from outside the application. Because if you only do based on CPU, you could actually go spin up and basically after you're in the peak, imagine you have a peak. And you should always also look at what's been happening until that moment. And so use that in order to do the auto-scaling. So normally when you have a single metric, you should look at it better because it's normally a combination of metrics. So in this case, when the new one comes up, we immediately get the other one scaled down. Don't forget to scale down. I will never forget the first time I saw Windows Azure on PDC 2008. A presentation. There was a lessons learned from the Link team. In that case, it was still live meeting, where they show the graph saying we're using Windows Azure, and whenever more people start to go into the room, into the meeting, we scale more instances. Look at this. And suddenly, after a while, they shut down all the meetings, and the graph was still there. And they went to something like 30 instances. They shut everything down, and the 30 instances would continue there. And suddenly in the Q&A, there's a question that is actually made by me. Is there a problem there with the auto-scaling? Does it only scale up? And they said, oh, I forgot to scale down. So they only had the auto-scaling working for up, not for down. So do not forget that unless you're Microsoft or you have big pockets. So in this case, fairly quickly, higher cost and cold, but it will provide you with a pilot. And the pilot is important because, as I was saying, when we switch from one end to the other, while we're switching because the region failed, a lot of other people might actually be doing the same thing. And that might be capacity issues. Another thing is hot DR. Yep.
If we use the new feature of Azure of stopping VMs, right? Is this still considered as a warm DR?
No, warm DR is when they are actually running, because they are prepared to receive very little but a little bit of result. That will be considered cold DR, because I actually need something to spin up, okay? But at least there is one thing that for now we can get creative, and I can have actually a lot of machines already there and just spin it up whenever I need. One thing that is important, if you go when you stop, there's one call out that is saying it's deprovisioned. So it's only on storage, and you'll require also to get provisioned by the Fabric controller. So, but that will be, at least the machines are there ready, and you can start. But that will be more considered cold DR. Yes, that would be a good middle ground. Yeah. Exactly. So the question is, that's a lot better because we already have the machines there ready, so the recovery time will be a lot faster, and it's true. Recovery time will be a lot faster, so that can be also a creative solution in order to achieve that. So in the hot DR, what we have is basically we have almost a replica, or normally it's a replica of whatever is in production is actually getting the hits we'll have in the other one. And in this case, what we are going to use is replication between them. And the application, if one failed, the other one immediately kicks off, and everything is there. Now, why do I need exactly the same level? I don't need the exact same level. I need to get the level, the minimum level, in order to keep my SLAs. So for example, I'm currently hitting a peak in my usage on my main one, 10,000 concurrent users. But I actually have, my SLA is only 6,000. So my data center 2 should actually only be prepared to support my SLA max. From there on, it just will auto-scale. Make sense? So in Windows Azure, one option would be, if we use SQL database, we would use replication, in this case SQL data sync, for example. Traffic manager, if one gets killed by anything, the other one is already there with the minimums SLA. We don't even feel anything from crossing boundaries. And when the main one comes back, it will immediately get there. Yes?
Wondering, what are the replication options for blob storage for SQL?
Only third-party tools. Only third-party tools. One of the things you can do is you can, for example, use a cron job to schedule, for example, the copy blob API in order to go grab things from one to the other side. That's one option, cheaper option, or you can get some third-party tools. So in order to do that replication. So it's higher cost, yes, because the other one, the second location, is actually really hot. It's really prepared to receive all the capabilities or most of the capacity that is being served. So it's normally very, very expensive. But the recovery time in here will be less than 5 minutes normally, around 5 minutes. It's when we choose this when we say my recovery point objective is around 5 to 10 minutes. My recovery time objective is around 5 to 10 minutes. Then I need to have everything prepped on the other side already. Another thing, and when this starts to get into these elements, another thing we can use is also get more creative, and everything we write, instead of having replication, which will affect the performance, we can actually get service bus and say, I will write immediately, my application will write immediately to the tables in the database, but would also send a message to the queue that is going to have a process, a worker on the other side, receiving and putting together. This way, my recovery point is actually a lot lower because everything is there already without causing performance along the way. Okay? So this, when it fails, everything is ready for getting, and then it fails back over. So we have similar deployments on both sides. In this case, instead of using SQL data sync, we are using service bus. What it provides us is getting more accurate and less impactful on the performance itself. Yes?
What is the difference between using asynchronous replication of the database? Asynchronous, so
Yes.
you don't impact performance of the
Exactly. But for that, we would...
because you have now people which is event that normally you push the data.
Yes. 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 Exactly. So it's very similar to asynchronous replication. The problem here is with SQL database, I don't have an asynchronous replication. If I want, I need to build it myself. Service bus is actually, normally it's there already, because when we want reliability, availability, and scalability, service bus or some kind of queuing system is already there. So actually that is not going to bring anything new into the table. And so that will bring you with everything is synced. And we have even another one, which is even getting more creative, which is, for example, even with SQL database, we have, how many of you know that SQL database has underneath 3 replicas? Okay, we have 3 replicas. When we create the database in SQL database in Windows Azure, we have 3 replicas underneath, primary, secondary, and tertiary. So, but there's one thing. Primary and secondary are always in sync at any single point in time, are always in sync. Why? Do you know? Because what you're actually connecting, when you do the connection string and you start to use TDS protocols and sending the queries and everything, you're actually hitting a load balancer. That load balancer will send the requests to both primary and secondary. Only when both of them tell you, send it back saying, I'm okay, everything was stored correctly, is when SQL database is going to tell you it's okay, your query went okay. That's why it takes a little bit more time. Okay? That makes sure that if primary goes away, immediately I have the secondary is up to date because it always gets stored at the exact same point in time. We can actually do the same thing with our applications. And that's actually when we need the RPO is immediate and the recovery time is around 5 to 10 minutes, then we would use something like this. That is, my application, when it stores, it doesn't store only in this database, it stores in the other database at the same time. And so, if I fall back with Traffic Manager, if I fall back from one to the other, immediately everything is there because I always wrote in there. Same thing SQL, same thing for table storage, blob storage, anything. Costs more, yes, but that means that now in something like 5 to 10 minutes, I can put that together. And I can keep my SLAs. Correct? So it's a matter of choosing the right approach and the costs that are going to get impacted. So it very quickly to get there. So we saw 3 options. All of them have different RPOs and RTOs. We first started with an RPO of around 30 minutes in this 20 minutes in this hot. We went for something like 5 minutes, and now we're on the immediate. And the RTO, the same thing. We started with around 30 to 25, 30 minutes, and we're now at the point at 5 to 10 minutes. So we have several options in there. And the final option is, of course, high availability. And high availability will provide you, of course, both of them are at the exact same time working. For that case, I wouldn't recommend SQL database. So for that case, and even for hot DR, when we are going on that route, probably SQL Server on a VM is a lot better for us. And in this case, what we were going, so we have both of them answering. If one fails, okay, I just lost part of the capability. I can also put this HA with another VR, so I can put this 2 in HA and a second one in warm DR, for example. If one of them fails, it will immediately fall to the other one. And so I will continue on. In Windows Azure, see that I actually placed SQL Server on a VM and not SQL database. What I can do is the replication. What replication should I use? If it's 2012, hopefully it will, I will use always on active. Because that means they are synced. They can actually have, I can do, for example, put one as master and as a slave in active passive. In this case, both can actually have changes. And they are working at the same time. And it's very very low impact on performance. And I can actually go from one end to the other without even noticing it. Okay? Yes?
So in that case, we'll have just one instance of SQL Server in one data center and one in another.
No, we will have two SQL Server machines on one region, two SQL Server machines in the other region. Between them, these two are in the same availability set in active-passive, and between the two regions, active-active.
One witness, I think,
With
witness.
yes, and we will have one machine that will be the witness. It's the one that says yes, actually they are both in sync, or they are actually doing this. Okay. Let's see how we are in time. Looks good. Okay, so basically, if one fails, the other region comes up. Then, very important, HA can be used a little bit as a DR, but it's not the DR strategy. It's a high availability strategy. If you want to have, this will provide you higher SLA. All the other options did not impact the SLA. The SLA was always the same. Now the SLA is higher. So if you have high availability, I strongly recommend you to have also hot DR involved. Because if you place together high availability because of your SLA, of course your SLA is not going to cope with cold DR. Okay? Does this make sense? Sorry? Traffic manager? Redundancy. Oops. Okay, traffic manager, the service itself would provide redundancy. When we go for big projects, if we are going for a very big project, I would actually recommend you to look at the Akamai Global Traffic Manager. Okay? Traffic Manager, Windows Azure is there. We'll get some things getting better. If you are on a HA kind of scenario and very important, I would actually recommend you to do a few tests, Traffic Manager and Global Traffic Manager from Akamai, which is really, really good.
In this scenario and in the hot DR,
Yes?
if someone messes up with data, for example, the user table, what's going to happen to the DR side?
Okay, great question. If both in this and basically all of them, if some user goes and drops a table, what happens to the DR strategy? That's where the backups are really important. DR is about processes for hardware, software, and people failures. So one of the people failures is the things, for example, thinking about hardware, Microsoft with Windows Azure will take care of the hardware problems. Okay? So they provide an SLA. We only need to consider if we want more than that SLA. Because in the infrastructure level, they work on it. Then, software, we are the ones that need to think about how are we going to cope with failures on the software. Are we allowing someone to go and drop a table? Okay, so we actually need to do something. We actually still have, in the cloud, there's need for backups because there's going to be issues somewhere along the way.
That can kill our SLA.
Exactly.
Can we, I don't know, I'm not really into Azure, but if you could take some snapshots on the block storage to keep pointing times.
Yes, you can.
Maybe on the disaster recovery side, maybe we can go back 1 hour
before. Yes. The question is, can we leverage snapshots, for example, if we are using SQL VMs in order to create snapshots of the VM and return back? Yes. Yes, it's possible. And it's a good option also to keep in mind. Any more questions? Okay, so conclusions. Plan for failures. They will happen. Make sure you plan for it. And disaster recovery is always depending on your application. So, for example, we did a solution in Windows Azure, which is an emergency response system. Okay? By the name, you already know that it should be important, right? The SLA should be high. And I can now tell you that it was for a nuclear power plant. So the SLA now gets even higher, correct? Because if something goes wrong, I need to know it's the emergency system that tells everyone something is about to happen. And we were planning for the DR, doing the DR, high availability, all that stuff. And the customer is saying, oh, 99.9 is enough. Of course it wasn't enough. If some problem goes, what needs to happen? And we were actually putting together a couple of options to discuss with customer, something like different hot DRs, strategies, and also high availability and so on. And I actually put together one just as a joke, which was I had one deployment in high availability, and then I had in the drawing, I had a person that was our backup strategy. And I placed the name of that person. It's someone that actually works with me in the company. Because that person actually lived just close to the nuclear power plant. And so I said, the customer doesn't want to pay more, so here is how it's going to work. The DR will be, if you see that that blows up, you start running and call us, and all the system will kick off. And for some reason, he didn't like the joke. So, important is you need to adjust your SLA and your DR with what you're going to do. It doesn't make sense to do a not DR in something that can be stopped with 8 hours and nothing comes to mind. For that, the cold DR is more than enough. Backups and a cold DR is more than enough. So adjust that. Talk with the business and IT. Do not talk with the IT people only. Do not go to the IT guy and say, what's the SLA? He's going to give you a number which is 7 nines because it just made it up. Business. What's the business going to provide? It's the important thing. Plan, understand the RTOs, the RPOs, understand the business, and choose the right one based on the RTO and RPO. Again, DR does not affect SLA. The SLA was always the same. The SLA in terms of availability was always the same. The recovery time was different in all the options. So if the SLA has first part availability, 99.95, it's one thing. Recovery time will affect the SLA a little bit because I need to recover in 5 minutes, so I need an RPO and RTO. Those are the most important things. Continuous improvement and plan DR always in your application today, even single applications. Even like me, our blogs for the community, we should have a DR strategy in place and backup strategy in place. So, thank you very much. A couple of resources that you can use. Evaluate this session and questions. Yes, normally you would use always on in order to get that, and it actually works really well, and it takes a little bit to configure, but works really, really well, and it's really quick to recover. But again, it depends on the type of failure that you have. You should have the strategies of VR should depend on the type of failures that you have. If it's a hardware fail, it's one thing. It's if it was a person failure which affected the database, it's another thing. It's going to take more time. Yes?
How will be consistent the team that will decide the policy of disaster recovery? Means the composition of that team will be how many IT guys, how many development architects, how many business guys.
Okay. So how should the composition of the team that decides the strategy for DR should be? Should have it depends on the numbers depends on the company, but should always have one person from the business, the product owner, someone higher, some VP or something like that, the product owner which has all the business elements, an infrastructure person understanding all the infrastructure, the architect, enterprise architect, solution architect, and developer in order to get that, and DBAs if we have. So all of them should be involved because all of them should be in sync. There will be a VR strategy for the DBAs, a VR strategy, how our application needs to be built in order to get that right from the start, and all of that stuff. So all of them should be. But at least business person, product owner, architects, and infrastructure. Those are the minimum you should put on a room. And you should close them on a room. Yes?
Because VR is a decision that should be taken within the organization. I mean, I don't think it is Windows, Azure can help because it's only backup and restore, right?
Yes. So cold DR is a decision. The question is, a cold DR is a decision within the company, and Windows Azure cannot help. Not actually true and not true at the same time. So yes, is a company decision. Windows Azure can help in the way that you can do cold DR, and we were using cold DR for Windows Azure deployments, but you can also do your DR strategy into the cloud because it will be cheaper, the storage, and to get everything there. And if you already have in the cloud, if you don't want to increase the cost, you will put on-premise or in another region. So it's yes and no at the same time. Yes, it's dependent on the company policy, but yes, Windows Azure can help a lot. No, the restore will happen. So what happens is I get the backups. Imagine I have this here, which is my application, which is in Windows Azure. I get the backups into the on-premise. But then I need to send the backups back to the Windows Azure, restore the Windows Azure in order to bring up again the Windows Azure element, the application. Because in that case, we were talking about only running in Windows Azure. And so the backups were going on-premise for cost reasons. It can go to any other region, but for cost reasons, I was sending into on-premise. But the goal is we have the backup somewhere else. It's not like actually today I actually did something different, which is I normally have my backups. I always do backups. The only problem is that they are in the same place where the machine is. So if I lose one, I lose everything. That shouldn't be the case. And in order to avoid that, you should place somewhere else, in another data center, or in on-premise, or in another region. Yes, so if a disaster occurs, I will run a script in order to recover in the cloud again, maybe in a different region, if that region is completely down in a different region, but use that backup in order to get it together. Yes?
We discussed about multi-cloud strategy.
Okay, so when should we look at the multi-cloud VR versus a multi-region? For example, if I have 5 nines, there is no way I'm going to get 5 nines with a single cloud involved. So for that, I will need to have probably HA in 2 regions in the same cloud provider, for example, and fail over to a secondary cloud. And in order to achieve that, probably a third one, which will be on-premise. And then depends. But only when we are talking about 4 nines, 5 nines, we will be talking about going definitely to multi-clouds. Anything else? So thank you very much again.